Hello students, in today's session we are going to see what is moment of inertia. The topics which we are going to discuss in today's session are what is moment of inertia? What are the different types of moment of inertia? What is the significance or importance of area moment of inertia? And what do you mean by the centroidal axis or neutral axis? What is parallel axis theorem? Perpendicular axis theorem, and the moment of inertia of some standard shapes of the figures, standard formulas, and some numerical examples. Okay. Now, what is moment of inertia? See, here there are two words, moment and inertia. So, what is moment? What is the tendency of the moment? So, the moment tends to rotate the body. Am I right? And inertia. What do you mean by inertia? It is the property of the body by which it offers resistance to change its state of rest or motion. So simply, it tends to resist to change its state of rest or motion. So the moment of inertia. So moment of inertia means it is the property of the body by virtue of which it offers resistance to the rotational motion. Resistance to the rotational motion. That is moment of inertia. So the moment of inertia is calculated by taking the second moment. By taking the second moment about a particular axis. Second moment means what? Moment of moment. So it is moment of moment. Is it clear? Now, what are the different types of moment of inertia? There are two types of moment of inertia. One is area moment of inertia and second is mass moment of inertia. So, area moment of inertia is defined as it is the second moment of area about a particular axis. Similarly, mass moment of inertia is the second moment of mass about an axis. But in this topic, we are going to study in detail about the area moment of inertia. Now, what is the SI unit? SI unit of area moment of inertia? Yes, moment of area means area into distance. We are taking moment of area. So, area into distance. Then the second moment means moment of moment. That is area into distance into distance. So it is area into distance square. So area is measured in mm square, whereas distance in millimeters. So it is distance square. So SI unit of area moment of inertia is mm raised to 4. Understood? Now what is the significance of area moment of inertia? Where it is used? Let us consider a rectangular section. So there are two sections, rectangular sections, but the orientations are different. So here it is kept in a vertical position, here it is kept in horizontal position. But the total area of these two sections is same. Let this axis is passing through the center of gravity or centroid of the section. So it is known as centroidal axis. Right? Similarly here we have an axis passing through the centroid of this section. Now if you take the second moment of area about this centroidal axis for these two sections. So I am taking moment of the area about the centroidal axis. So the centroid of this portion of the area will be at its midpoint, right? Similarly here, the centroid of the upper portion of this area, which is in yellow color, midpoint is its centroid. So the distance of centroid of this area from this axis is, say, y1. Similarly here, the distance of centroid of the area, which is in yellow color, about this axis is y2. Now if you take moment of area about this axis, moment is equal to area into distance. Area of this upper portion is a by 2 into distance y1. Am I right? So the second moment of area means again multiplied with distance y1. Whereas here, the moment of this upper portion, yellow color, area about the axis is a by 2 into, here distance is y2. Because the total area of the both the sections, it is same. So half of that area is a by 2 for both the sections. So again here the second moment means again multiplied by y2. So for the total section, it is multiplied by 2 multiplied by 2. So here you have a into y1 square, whereas here again it is a into y2 square. Am I right? But area is same in both the sections. But you will find that y1 is greater than y2. That means the first section, the section which is in vertical position, is having more moment of inertia than the second section, being the total area is same. Are you getting my point? So the section 1 is having more moment of inertia in this position than section 2. That means moment of inertia, it indicates the quantitative relative distribution of area about an axis. Here you will find that the area is distributed far away from this axis, whereas here the area is distributed very near to the axis. Though the total area of these sections is same, the moment of area, second moment of that area, that is moment of inertia of this first section, is greater than the second section. Therefore you will find the resistance of this section to bend is more than the second section. Now say, let us consider this scale. say the cross section of the scale is like say in rectangular section. Now when you keep this scale horizontally and if you try to bend the scale, you can bend it very easily, am I right? But if you keep the scale in a vertical position, the cross section is vertical, and if you tend to bend the scale, so it is very difficult. It is having more resistance against bending because it is having more moment of inertia about this axis, that is as in the case 1. So here the section is vertical. Here the section is vertical. So it is having more resistance against bending than the second section. Why? Because the first section is having more moment of inertia, more area moment of inertia. So in practice, generally you will find all the beams are placed in the structure in a vertical position only, in a vertical orientation, means the area of cross section of the beam is in a vertical position than horizontal, because beams can resist bending. It is having more resistance against bending in vertical position. Understood? That is the importance of area moment of inertia. Now neutral axis. So here neutral axis is nothing but centroidal axis. So let us consider this section having center of gravity or centroid as G. The axis passing through the centroid of a particular section is known as centroidal axis. Centroidal axis, which is also called as neutral axis. Now see here, this beam is supported by two simple supports. Let load W is acting at the center of the beam. This is the neutral axis or the centroidal axis, the axis passing through the centroid of the section, cross section of that beam. Now because of this applied load, you will find that the beam bends, right? So in the bending position, you will find the fibers or layers of the beam above this centroidal axis are in compression, and the layers of the beam below this axis as in tension. Means all these, the portion of the beam above the neutral axis is subjected to compression and below the neutral axis subjected to tension. Whereas you will find that there is no stress along the neutral or centroidal axis. Here there is no tension, no compression. Hence the name neutral axis. Is it clear? So above the neutral axis, the beam is subjected to compression. Below the neutral axis, beam is subjected to tension. But along this centroidal axis or neutral axis, there is neither tension nor compression. Hence the name neutral axis. Understood? So simply neutral axis is nothing but the centroidal axis. What is centroidal axis? The axis which is passing through the centroid of the given section. Now parallel axis theorem. Parallel axis theorem states that the moment of inertia about any axis, the moment of inertia is indicated by the letter capital I. So the moment of inertia about any axis which is parallel to the centroidal axis is given by, say here AB, axis AB is parallel to this centroidal axis. So the moment of inertia about an axis which is parallel to the centroidal axis is given by, so the moment of inertia of the section about the centroidal axis, about an axis passing through the centroid, plus AH square, where is A is the area of cross section, total area of cross section of this figure, and H is the distance between the two parallel axes. Are you getting me? Here, what is IAB? It is the moment of inertia about an axis parallel to the centroidal axis. Whereas IG, so it is the moment of inertia of the section about the centroidal axis. Centroidal axis which is parallel to the given axis AB, and A is the total area of cross section. H is the distance between the two parallel axes. So what are those two parallel axes? One is the axis AB and other is the centroidal axis. So this is parallel axis theorem. Understood? Now perpendicular axis theorem. Say G is the centroid or center of gravity of the section, and this x and y axis are centroidal x and y axis, and here z axis is perpendicular to the xy plane. So as per perpendicular axis theorem, the moment of inertia about an axis which is perpendicular to xy plane, that is nothing but z axis. So the moment of inertia about z axis is given by the moment of inertia about its x-axis plus moment of inertia about the y-axis. So this is perpendicular axis theorem. Is it clear? So here z-axis is perpendicular to xy plane. So moment of inertia about z-axis is equal to moment of inertia about x-axis plus moment of inertia about y-axis for any given section. Then moment of inertia for standard shapes. So here is the rectangular section having width B and height or depth D. So here x and y axis, they are passing through the center of gravity or centroid. Then the moment of inertia about the centroidal x-axis for a rectangular section is given by B d cube by 12. Then moment of inertia about the centroidal y-axis is given by B cube d by 12. So you have to remember these formulas. This is about x-axis and about y-axis. Suppose if you want to calculate the moment of inertia of this rectangular section about the base of the rectangular section. So moment of inertia about the base of the rectangular section. Here we have to use parallel axis theorem. That means I want to calculate the moment of inertia about this axis, which is parallel to the x-axis. So what is the distance between these two parallel axes? So nothing but h, which is equal to d by 2. Right? So as per parallel axis theorem, moment of inertia about an axis which is parallel to the centroidal axis is given by moment of inertia about the centroidal axis plus AH square. Now here, what is the moment of inertia about the centroidal x-axis? B d cube by 12. So it is B d cube by 12 plus what is the area of the section? B into D, whereas H is D by 2. So H square D by 2 whole square. So this gives you BD cube by 12 plus BD cube by 4. That is equal to BD cube by 3. So it is the moment of inertia about the base of the rectangular section. Similarly, you can find out the moment of inertia about the side of this. Using same thing, parallel axis theorem, the distance between this side and y-axis, now it is B by 2. So you will find that B cube D by 3. Understood? So rectangular area. Here, the external dimensions of this rectangle are B and D, capital B, capital D. Whereas for inner rectangle, it is small b and D. So the moment of inertia about the centroidal x-axis is given by B D cube by 12 for the external rectangle minus B D cube by 12 for the internal rectangle. So it is 1 by 12 into capital BD cube minus small BD cube. Okay. Similarly, what is the moment of inertia about centroidal y-axis for this hollow section? 1 by 12 into B cube D minus small b cube D about y-axis. Now let us consider square here. For square, B is equal to A, right? Hence, the moment of inertia about x-axis is equal to moment of inertia about y-axis is equal to, yes, A raised to 4 by 12. It is B D cube by 12, B is equal to D, which is equal to A. So it is A raised to 4 by 12. For circular section, here diameter of the circle is D, and this circular section is symmetrical about x and y axis. So the moment of inertia about the centroidal x-axis is equal to moment of inertia about centroidal y-axis is equal to pi d raised to 4 by 64, right? Where d is the diameter of the circle. And can you tell me what is the moment of inertia about the z-axis using perpendicular axis theorem? So moment of inertia about an axis perpendicular to xy plane is given by Ixx plus Iyy. So that gives you pi d raised to 4 by 32. So this is also known as polar moment of inertia, because the z-axis is known as polar axis. These formulas are to be remembered. The derivations will not be asked. To solve numerical examples, you must know, you must remember these formulas. Now for a hollow circular area, so the external diameter is d and internal diameter is small d. The moment of inertia about the x-axis is equal to moment of inertia about y-axis, which is equal to, yes, it is pi upon 64 into capital D raised to 4 minus small d raised to 4. This is for a hollow circular area. Now semicircle. For a semicircle, the moment of inertia about the base of the semicircle, that is about the x-axis over here. Remember, this x-axis is not the centroidal x-axis. It is along the base of the semicircle. Right? Is given by, it is pi d raised to 4 upon 128. For circle, it is pi d raised to 4 by 64. So for a semicircle, divided by 2. That is pi d raised to 4 by 128. Suppose, and this is also equal to moment of inertia about y-axis. If you want to find out the moment of inertia about the centroidal axis, so about the axis passing through the centroid, then what you have to do? You have to use parallel axis theorem. Here the distance between these two parallel axes is 4r by 3 pi. Is it clear? Now for quarter circle. The quarter circle, the moment of inertia about x-axis is equal to the moment of inertia about y-axis is equal to pi d raised to 4 by 256. Okay. So for circle, pi d raised to 4 by 64. For semicircle, divided by 2, pi d raised to 4 by 128. Quarter circle, further divided by 2. That is pi d raised to 4 by 256. Whereas for triangle, so for triangle, the moment of inertia about the base, moment of inertia about the base of the triangle is given by b h cube 12. B is the base of the triangle and h is the height of the triangle. Now let us solve the examples. For a rectangular section shown in figure, compute the values of Ixx, Iyy, Iab and Ipq. So you have to calculate the moment of inertia about 4 axes now. So about the x and y axis, these are the centroidal axis, say passing through G. Whereas moment of inertia about AB, that means base. And a moment of inertia about PQ. PQ is the line which is located at 50 millimeters from AB. So this is the given figure. Now you have, for this rectangular section, B as 90 millimeters, D 160 millimeters. So first, moment of inertia about the centroidal x-axis. So directly you can use the formula B d cube by 12. So it is 90 into 160 cube by 12. That gives you 30.72 into 10 raised to 6 mm raised to 4. Then second one is moment of inertia about the centroidal y-axis. What is the formula? B cube D by 12. So here 90 cube into 160 upon 12. That gives you 9.72 into 10 raised to 6 mm raised to 4. Then what is the third part? So you have to calculate moment of inertia about base. That is moment of inertia about the axis AB. So you can use directly that formula, or otherwise what you have to do? you can use from first principles. Using first principles, that is parallel axis theorem, you can find out moment of inertia about AB. So moment of inertia about AB is equal to moment of inertia about the centroidal axis plus AH square. So moment of inertia about centroidal x-axis is given by 30.72 into 10 raised to 6 plus area of the section 90 into 160 into h. H means distance between the centroidal x-axis and the line or base AB. Right? This is your h, which is equal to 80 millimeters. So it is 80 square. So this gives you 122.88 into 10 raised to 6. Right? Then the fourth part, that is moment of inertia about the line PQ. Now again, this line PQ is parallel to x-axis. You can use parallel axis theorem. So it is moment of inertia about the centroidal axis plus AH square. But here, what is h? H is the distance between these two parallel axes. So that is 80 minus 50. That will be 30. Am I right? So this is equal to 30.72 into 10 raised to 6 plus area of the section. It is same 90 into 160. But here h is 30 square. So that gives you 43.68 into 10 raised to 6 mm raised to 4. So now we have moment of inertia about the x-axis, centroidal x-axis, centroidal y-axis, moment of inertia about AB, and moment of inertia about PQ. Understood? Now let us see another example. So it is a composite section. Find the moment of inertia of T section shown in figure about the centroidal x and y axis. Please note this. Centroidal x and y axis means the x and y axis which are passing through the centroid of this figure. So first you have to locate the centroid of this figure and then you show the x and y axis. So to locate the centroid of this figure, I am dividing this figure into two rectangles. Say the upper rectangle 1 and the lower rectangle 2. And this figure is symmetrical about the vertical axis. Right? So it is symmetrical about vertical axis. I am considering that symmetrical axis itself as y. Then I am taking this as the origin. Say this is x-axis. So being it is symmetrical about y-axis, x bar is 0. Only now we have to find out y bar. That is distance of centroid or center of gravity of this figure from x-axis. So this is y bar. Now to find out y bar, first you have to calculate a1 y1, a2 y2, right? So a1, area of the upper rectangle, 120 into 20. So 2400 mm square. Now y1. What is the meaning of y1? Distance of centroid of this upper rectangle from the x-axis. So we know that this is the midpoint, is the centroid, and its distance from the base of this rectangle will be 10. but we want distance from x-axis, right? So what is the distance from x-axis to the base of this rectangle? Total height is 150 minus 20. So you have this distance as 130. Now in our case, what is y1? So it is 130 plus 10, right? Total distance of centroid of rectangle 1 from x-axis. So this will be 140. Now A2, area of lower rectangle. So it is 20 into, what is the height of this lower rectangle? 130. So it is 2600. Now y2. G1, centroid of the upper rectangle. Now here y2 means distance of centroid of the lower rectangle from x-axis, right? So this distance is y2. So the midpoint of the lower rectangle is the centroid. So the total height of the rectangle is 130. So half of that, 65, right? So now y bar is equal to summation ay upon summation a. So a1 y1 plus a2 y2 upon a1 plus a2. So putting these values and doing calculations, you will find that y bar is equal to 101 millimeters. So that is the first step to find out the position of centroid of the figure. Why it is required? Because to locate the centroidal x and y-axis. So this is y-axis. And you are asked to find out the moment of inertia about the x-axis which is passing through the center of gravity. Are you getting me? Not here, the base. So you have to look at moment of inertia about this axis. Understood? Okay. Now, the moment of inertia about the centroidal x-axis of the entire figure is equal to the moment of inertia about the centroidal x-axis of rectangle 1 plus moment of inertia about the centroidal x-axis of rectangle 2. Is it clear? So now, moment of inertia about the centroidal x-axis of rectangle 1 is equal to. Now, we are finding moment of inertia about the axis which is passing through the centroid of this entire figure. But whereas for rectangle 1, G1 is the centroid. Am I right? We are having formula for the centroidal x-axis of this rectangle. So that is IG1 using parallel axis theorem. Moment of inertia about an axis which is parallel to centroidal axis is equal to moment of inertia about centroidal axis plus a h square. I am saying a1 h1. Are you getting me or not? We are finding moment of inertia about the centroidal x-axis of the entire figure. Whereas for rectangle 1, G1 is the centroid. So the axis passing through the centroid is its centroidal axis. So using parallel axis theorem, moment of inertia about any axis which is parallel to the centroidal axis is given by, so moment of inertia about centroidal axis plus a h square. Here h is distance between the two axes. In our case, it is h1. Is it clear? So the moment of inertia about the centroidal x-axis of rectangle 1 What is the formula? B d cube by 12. B is 120, D is 20. So B d cube by 12 plus A1, area of rectangle 1, that is 2400 into H1. So what is the H1 here? We know that Y bar is 101, right? So this is 101 millimeter. So the total height is 150. 150 minus 101. How much is this? 150 minus 101. That will be 49. So here H1 is this 49 minus 10. So that will be 39. So 39 square. Is it clear? So we have this as 10 now. So total this 49 minus 10. So IXX1. So it will be 3.73 into 10 raised to 6 mm raised to 4. Similarly, moment of inertia about the axis, centroidal axis of the entire figure for rectangle 2 is using again parallel axis theorem. It is IG2 plus A2 H2 square. So here G2 is here. The axis passing through G2 and the axis of the entire figure. The distance between them is H2. Right? So what is H2 here? 101 minus 65. Right? This will be 65. You have this as 65. So 101 minus 65. So how much is that? 36. That is H2. So now here IG2 means moment of inertia about centroidal x-axis of rectangle 2, BDQ by 12. But what is B for rectangle 2? 20. So it is 20 into D. Depth of this rectangle 2 is 130. So BDQ by 12 plus area of rectangle 2 2600 into H, that is H2, we are having 36. So this gives you 7.03 into 10 raised to 6 mm raised to 4. Therefore, moment of inertia of the whole section about centroidal x-axis is IXX1 3.73 plus IXX2 7.03 into 10 raised to 6. So that will be 10.76 into 10 raised to 6. This is mm raised to 4. This is the final answer. Now, to find out the moment of inertia about the centroidal y-axis. But see here, the y-axis, the centroidal y-axis is same for the entire figure, for rectangle 1 and rectangle 2 also. Right? See the centroid of rectangle 1 G1, the centroid of rectangle 2 G2, the centroid of the whole section G. All these three are located on the y-axis. Am I right? So this y-axis itself is the centroidal axis for all the rectangles and the entire figure. Hence, no need of using parallel axis theorem. Am I right? So IYY for the entire section is equal to IYY1 for rectangle 1 plus for rectangle 2. So what is the formula for moment of inertia about y-axis? B cube d by 12. For rectangle 1, B is 120. So B cube d is 20 by 12 plus rectangle 2, B is 20 over here, right? B cube d is 130 by 12. So this gives you 2.967. 2.967 into 10 raised to 6 mm raised to 4. So this is the moment of inertia about centroidal x-axis, and this is moment of inertia about centroidal y-axis. Understood? So we'll see one more example. Find the moment of inertia of a hollow section shown in figure about an axis passing through its center of gravity. About an axis passing through its center of gravity. So, hollow section means from this rectangular section, the hole is removed. Okay. And the radius of the circular hole is 75 millimeters. So this figure is symmetrical about, yes, vertical axis. It is symmetrical about vertical axis. So the centroid of this section will be located on the symmetrical axis. And taking from base, I am taking this as x-axis, y-axis. We know that the centroid will be located on the symmetrical axis, centroid of this entire figure. Let us say centroid is over here. Its distance from x-axis is y bar. So this is the axis which is passing through the centroid. So you are asked to find out the moment of inertia about this axis, centroidal x-axis. You should not confuse with this x-axis and the x-axis which we have taken. You are asked to find out a moment of inertia about the axis which is passing through the center of gravity or centroid, right? So we have to find out y bar. So for that you can divide this section into two parts. One is the rectangle, the whole section, and second is circle. So rectangle minus circle, you will get the remainder. So A1, area of the rectangle, 200 into 400, right? So 80,000 mm square. Now y1, distance of centroid of this rectangle from the base. Total height is 200. So y1 will be, total height is 400. So y1 will be 200. Then A2, area of the circle. So it is pi r square. R is 75. Distance of centroid of the circle from the base, from here. So it is total height of the rectangle is 400. Center of the circle from top of the rectangle is 100. So therefore y2 will be 300. Right? Now putting all these values, calculating y bar, that is A1 y1 minus A2 y2 upon A1 minus A2. Minus because the circular portion is to be removed. You will get it as 171.65 millimeter. 171.65 millimeters. So this is y bar. Right. Now to find out the moment of inertia about the centroidal x-axis. So moment of inertia about centroidal x-axis is equal to Ixx1 minus Ixx2. Why minus? Because the circular portion is to be removed, right? So moment of inertia Ixx1 means moment of inertia of rectangle about the centroidal x-axis of the whole section. So for a rectangle, we know that centroid is located at 200 millimeters height. So this is the I will say G1. G1 is the centroid of rectangle 1 and G is the centroid of the whole section. So the distance between them is H1. Am I right? Distance between the two axes. So what will be the H1 here? H1 is equal to, yes, 200 minus y bar, that is 171.65. Distance between the two parallel axes, 28.35. 28.35. Now using parallel axis theorem, Ixx1 is equal to Ig1 plus A1 H1 square. Ig1 as per the formula BD cube by 12. B is 200, D is 400, BD cube by 12 plus A1 200 into 400 into H1 square 28.35 square. That gives you 1130.96 into 10 raised to 6 mm raised to 4. Similarly, you can find out Ixx2 for the circle. So for circle, this is G2, centroid of the circle. The distance between these two parallel axes, centroid of the circle and the centroid of the whole section, is H2, right? So what is H2 now? So total 400 minus 100. So up to center it will be 300. So 300 minus y bar. Am I right? So 300 minus y bar is 171.65. 128.35. 128.35. So Ixx2 is I2 plus A2 H2 square. Now for a circle, what is the moment of inertia about the centroidal axis? Yes, it is pi d raised to 4 by 64. Pi into diameter is 150. Radius is given 75. So pi d raised to 4 by 64 plus area, it is pi r square 75 square into H2 square, that is 128.35 square. So this gives you 315.96 into 10 raised to 6 mm raised to 4, right? So the total moment of net moment of inertia of the section about centroidal x-axis, Ixx1 1130.96 into 10 raised to 6 minus 315.96 into 10 raised to 6. That gives you 815.0 into 10 raised to 6 mm raised to 4. So this is our final answer. Understood? Thank you.